Hi everyone, my name is Emily and today I'm going to present to you guys my final project with titled AI-based IoMT risk monitoring system for the future 6G healthcare. As healthcare continues to adopt the smart technologies, the IoMT, or we known as the Internet of Medical Things, is becoming increasingly important. So IoMT consists of connected medical device that continuously collect and transmit the data patient. So, with the future introduction of the 6G network, the healthcare system will becoming faster, more intelligent, and highly interconnect between the systems. However, this increased connectivity also creates some new cybersecurity risk. There are some five major challenges that motivate this project. So first, healthcare systems face increasing security risk as the medical device become connected through the future 6G networks. Second, many AI security solutions operate as the black boxes, or meaning that the users do not understand how the predictions are made. So it is like the lack of transparency in AI-based security system. The third one is there are a growing need for explainable threat detections, especially in the healthcare where the decisions can directly affect the patient safety. The fourth one is the healthcare organizations must ensure the continuous service reliability because like the disruptions can delay the treatments or affect the patient monitoring. So the last one is the complexity of securing the IoMT device because like the IoMT device are often resource concept and widely distributed, making them is difficult to secure effectively. So to address this challenge, I developed an AI-based IoMT risk monitoring framework. And the primary goal itself is to detect the cyber attacks and also the abnormal conditions within the IoMT networks. The system also uses machine learning, specifically the model I will introduce in the next slide, to analyze the healthcare and also the network related parameters and classify the system conditions. And for the output itself, the model can predict some four possible states such as like the DDoS attacks, network congestions, device failure, and also normal operations. And also, I also provide some human readable explanation using the SHOP explainable AI model. So, for the dataset itself, the dataset itself was manually simulated and generated using the Google Colab. The simulation also includes several key parameters that commonly found in the IoMT environments. The feature itself includes like the heart rate, latency, CPU usage, and also the battery levels. And for the additional network-related parameters such as like the packet traffic or also the signal strength were also included. Although the data was simulated, it allows us to effectively test the performance of the proposed framework. So the machine learning that is selected for this project was the random forest because like the random forest is an ensemble learning method that combines the multiple decision trees to improve the prediction accuracy and also the reduce overfitting. This makes it particularly suitable for the classification problems involving the complex healthcare and also network data. After we train and also testing the model, the system achieved a prediction accuracy for about 98%. The confusion matrix itself shown here to demonstrate that the most of the instances were classified correctly across all of the categories. The high accuracy itself indicates that purpose framework can effectively distinguish between the normal and also the different types of threats. And to better understand how the model makes decisions, here are some future important analyses were performed. The first one is the most influential feature was latency. That is, if the system have the high latency, it may indicate the communication delays, network conditions, or potential attacks. The second one is the CPU usage. That is meaning that the unusually high CPU usage can weak the signal system overloads, device malfunctions, or malicious activity. The third one is the packet traffic with the 18.9%.
means that the sudden spikes in traffic often indicate the abnormal network behavior of the cyber attack, such as like the DDoS attacks itself. The third one was like the battery level, because like low battery level may affect the service availability and it will indicate that the device are approaching failure. And one of the most important aspects is like using the explainable AI. We use the SHAP model, and the SHAP itself help how much the each of the feature contributes to our predictions. Instead of just simply reporting that the device is just experiencing the DDoS attack or network connections, the model itself will reveals which factors influence the decisions. For example, high latency and also abnormal packet traffic may strongly contribute to the DDoS prediction. This transparency improves like the user trust in the system, and it allows the healthcare professionals to better understand the reasoning between each healthcare. Then, in healthcare application itself, this explainability is especially important because like, the decision must be both accurate and also accountable. So here are the project input and also output. So the users can basically enter several parameters, including like the heart rate, latency, packet traffic, CPU usage, signal strength, and also battery level. These values are then processed with the trained random forest model that I made in the Google Colab, and then the system will produce a prediction indicating the condition is normal or associated with a specific threat. In the example shown, the output predicts the normal conditions in here with the user input. Okay, to demonstrate the proposed AI-based IoT risk monitoring system, I tested some 4 different scenarios to represent the common conditions in a future 6G healthcare environment. So for the first one, if we enter, the heart rate is 90, latency 250, packet traffic 4,500, CPU usage 60, signal strength 70, and the battery level is 80. Then the device will experience very high network and unusually high packet traffic. So the common indicators is like the DDoS attack. And after entering the values into the system, the random forest may predict into like the DDoS attack. So for this one, we can run the cell and then the SHAP model shows that the latency and also the packet traffic itself is the most contributed to this prediction. And it helped us to understand why the AI reached these decisions. For the second condition, we will input again for the heart rate, latency, packet traffic, CPU usage, signal strength, and also battery level. So for this one, the device has like the very low battery level and also the weak signal strength, so that this condition suggests that the medical device may fail or become unavailable. And after processing the data, then we can run the SHAP also, and the SHAP explanation highlights the battery level and the signal strength as the most influential features in here. And the third condition is like we will enter the heart rate, latency, packet traffic, CPU usage, signal strength, and also battery level. Then the system will predict as the network conditions, because like the latency is high, then the CPU usage is overload, indicating that the device and also network are under heavy stress. And we run this cell, and the SHAP analyze that the latency and also the CPU usage are the most influencing key factors in the predictions. Then the last condition is like the normal one. If we enter like the normal heart rate, normal latency, normal packet traffic, CPU usage, here, signal strength, and also battery level, then the signal will predict as the normal one. And we can run the SHAP model itself. It will predict that the normal one, because like the SHAP explain that this system is having no risk related features that is significantly influenced behind the prediction, indicating that this system is the normal system behavior. Conclusion and also future work itself. So this project successfully developed an AI-based framework for monitoring the risk in the future 6G environment. The system have analyzed the healthcare and also network-related parameters. The random forest itself achieved a high prediction accuracy that demonstrates the strong performance in threat detections. Furthermore, the XAI model, which is the SHOP, provide the transparent explanation that improve the understanding of the model decision. And for the feature work itself, we can made several improvement. So first one, the framework should be evaluated using the real-world IOMT healthcare datasets because like for now, I only use the simulated one because I couldn't find any datasets that is contained between the IOMT and also the 6G assistance. Then for the second one, the additional cybersecurity attack scenarios can be incorporated to improve the robustness. And finally, the system can be integrated by using the actual IoMT device for the future 6G healthcare. So that concludes my presentation. This project demonstrates how AI and also the explainable AI can work together to improve this cybersecurity, reliability, and also transparency in the future IoMT healthcare system. Thank you for your attention. Bye bye.